Hi again, this is ECE109, Introduction to Electrical Engineering, lecture note number 5. In this section, we're gonna cover delta Y transformation. Two things we're gonna cover. How we can go from delta to Y, or how we can go to Y to delta, and why we need this one here. The reason we need this one here because sometimes in the circuit, when you look at, they are not look like real, they're parallel, they are look like not serial. What you gonna do? You need to make conversion. And basic example in this kind is a bridge circuit. Is an example here. If you look at the circuit here, I will use the red color here or green color. Let me use the green color here. When you look at this case here, these are not parallel here because of this one here. So when you look at this here, this looks like delta form. If you convert the delta to Y shape, then we can see these resistors are serial or parallel easily too also. The other term, it might be as like this here. Maybe I get blue one here. This is three of them. This is Y form. We can convert from delta form. We can solve two also. Otherwise, when you look at here, if you want to find the equivalent circuit, you cannot find it directly. So basically, if we have a delta Y form, I call R1, R2, R3, we can go to delta form, I call RA, RB, and RC right there. Okay? Or either way you can go. So you can go from here to here or the other way here. Whichever you feel comfortable or whichever you need to do it. Let me look at here how we can convert here. We put delta and Y in one circuit. In this case here, we're gonna go from delta to Y shape. We assume that RB, RC, and RA are given to you. So we're gonna find the equivalent circuit of that one in Y form as, let me change the color here. Maybe I will put the green one right there. R1, R2, and R3 form here. So that's why we call this one as delta to Y conversion here. So if you look at here, if you're gonna find the R1, R1 will be equal to adjacent resistor RB and RC here divided by total sum of the three resistor values. So same way, if we're gonna find the R2 is this one here. We're gonna look at the two adjacent resistor RC and RA here divide by sum of three resistors right there. Similar way, R3 is RB times RA divided by RA plus RB plus RC. So idea is, simple way to remember this one here, the numerator will be two adjacent branch resistance value divided by sum of the resistors. The other one is how we can go from delta Y to delta form. So in this case, we assume that R1, R2, and R3 are given to you. So you're gonna find the RA, RB, RA, and RC. Let's see here. So RA here. Look at the RA here. You will see RA, RB, and RC. The numerators are same. So RA, which is this one here, is R1 times R2, R2 times plus R2 times R3, plus R3 times R1, divided by the opposite side of Y resistor, which is R1 here. Okay? So when I look at the RB here, same thing, RB will be R1 times R2 plus R2 times R3 plus R3 times R1, the opposite side on the Y resistor, which is R2. That's why you're gonna have here. Similar way, RC will be equal R1 plus R1 times R2 plus R2 times R3 plus R3 times R1 divided by opposite resistor, which is here R3 here. So numerators are same, the only denominator change, which is the opposite side of the Y resistor. Okay, this is the simple way to remember them. If the whole resistors R1 to equal R2 plus R3, which is we call RY case, in that case RA will be equal RB plus will be equal RC will be R delta here. So when you combine together here, we see here RY will be equal R delta divided by 3. The other way, R delta will be equal to 3RY. That's the way you can, maybe, if they are equal same. Here one example, we have delta circuit here. Then we're gonna find the Y form here. So Y is looks like this one here. That's why we have R1 here. R1 here. The R1 will be equal basically RC times RB divided by sum of three resistance RA plus RB plus RC. If you're gonna look at R2, R2 is given to you in this case right there. That's why it will be RA times RC divided by sum of three resistors. R3 will be this way here. That's why RB times RA divided by sum of three resistance. Okay. Here one example. I mean, this case we have the voltage source here. We have a combination of resistance. Well, because of this, let me make this one is like this. Because of this resistor right there, there is no parallel here. There is no serial divided. So we need to make conversion. You can use the Y to delta if you want. In that case, you're gonna use this one here. You can do it if you want, or you can do delta to Y. Simple example or best idea to use this 3 here as delta to make conversion. So when you convert them delta form like this here, that's why we have here 1, 2, and 3. So easily you can find the 6 ohms is right there, which is equal to 30 times 20 ohms divided by 30 plus 20 plus 50. Same way, if you're gonna find this resistance right there, 20 times 50 divided by sum of three resistance. Okay, after combine them is form like after combine them in, let me erase one here. Then when you look at the circuit here, this case here, when you look at here, you can see this is serial, this is another serial, then parallel, then three resistance serial. That's why we'll look at them is easily here. We can do this way here. Okay, here I think this one plus this one here, this one plus this one parallel, then you add them together here to find the RAB. If you find RAB, then you can find the current is here 240 divided by the RAB value 6 ohms. There is another example here. I did not give you answer, but I want you to look at this one here. Try to solve this question before the class so we can discuss if you have any problem. Easily think about this one here. This is the delta here. You can convert them to Y form, then you can solve the problems after that one here. Okay, please make some question. If you have anything concern, bring it to class. We can discuss about it. Okay, talk to you next class.